على الساحل الشمالي لدولة قطر، عند ملتقى البر والبحر، تتشكل الكنوز. إنه عالم غريب ومعقد، شكلته قوى جيولوجية مهولة. أحياناً يبدو ككوكب عجيب، أو كبعد مختلف محاصر بين المد والجزر. مكان يضج بالمتناقضات، الساخن والبارد، الرطب والجاف، وعلى الرغم من ذلك فهو عالم يعج بالحياة. ولعدة قرون عاش الإنسان على سطح هذه الأرض، غير مدرك لما تكن في خفاياها. لكن هذا الامتداد الصغير من الأراضي الرطبة يخفي مصدر أعظم كنز في المنطقة، الهيدروكربونات.
Qatar, the first oil was found in 1940 at Jebel Dukhan in the west. So this also tells us something where the oil was found, because Jebel means mountain, Dukhan means actually mountain of smoke, right? So yeah, we were looking for surface expressions of domes or highs of the subsurface. And this was, in the old days, the easiest to go after hydrocarbons.
Many decades when people first discovered hydrocarbons in this area and other areas of the world, it was mainly just seeing a surface expression of the earth. You'd see, a bump, and you'd say maybe there's an accumulation there, and they would drill, and sometimes they would find, hydrocarbons.
I think it was hard because there was not much infrastructure, neither in Qatar nor in Bahrain. So it was also tough getting to these outcrops. So for instance, here in Qatar, they had help from a very knowledgeable Bedouin. His name is Sheikh Mansour. He's really famous. And he helped the geologists to find these outcrops where they could study the rocks. So with the help of Sheikh Mansour, actually, the Dukhan structure, or the Dukhan field in Qatar was discovered. It's always good talking to the locals if you do exploration. When you're in an area where you know nothing, it's good counting on what the people know already. And like Sheikh Mansour, he knew the area very well. He knew it so well that even after the war, he actually, problems with his eyes, actually went blind, but he still could find the outcrops, so, because it was in his memory. It's a pretty interesting story, actually.
It starts before life. The seas started to come in, the seas went out. The seas came in, the seas went out. And meanwhile, the plates were moving and shifting through time, right? And over that time, many deposits were laid down. You need a source rock. That source rock needs to be organically rich, little microbes that fall through the water column and settle down, and then it needs to be buried. And when it's buried with subsequent layers, eventually that little molecule of organically rich matter will cook with pressure and temperature and time, right? And it starts to form hydrocarbons. Those hydrocarbons are light and buoyant, and they'll begin to want to move up. Where will they go? They need to find a layer that has some porosity, some pore throats, some area for that oil or gas to accumulate. And here in the Middle East, we had the conditions were just right over a broad region to have a very rich source rock and have many reservoirs for those hydrocarbons to cook and to settle in, and then traps as well.
This over and over again, we had these favorable conditions, and that's this richness. And this has something to do with the position of Qatar or the Arabian Plate, always being around the equator and never experience any major tectonic events where you produce faults where the hydrocarbons can escape right vertically up.
We have limited data to be able to paint a picture of what is going on well below the surface of the Earth. We can't see it firsthand, we can't smell it, we can't touch it, we can't use any of our senses.
Al-Ruiz is an example of where we can go and understand what a reservoir looks like in the subsurface. And so we use that as what we call an analog, because we can't walk to a reservoir of oil and gas today, but we can walk to a beach, a shoreline, and from there it gives us, in our mind, it gives us an opportunity to kind of understand how that reservoir is constructed, its architecture.
We have data, and we have the laws of physics and how the Earth works, and then we can test hypotheses, right, and see what things may be below the surface.
So you always have to work with limited data, and you use your imagination to basically make up what's in between the wells. You can use seismic, right? These are sound waves that are sent down into the subsurface that show you something, but that's also limited from the resolution. So the best way actually to close the gap is to look to the modern environment, to use the modern as a key to the past or to the subsurface.
عند الوصول إلى الرويس، هذا هو المنظر الذي يستقبل الزائرين. مساحة من الأراضي القاحلة تحيط بها أشجار المنجروف الكثيرة، وكذلك الشاطئ. لكن هذا المنظر الذي قد يبدو مألوفاً للعيان يخفي بقايا تاريخ قديم للغاية، ومفتاحاً قد يمكننا من فهم كيفية تشكل آبار النفط والغاز. هذه الكثبان يبلغ عمرها 120 ألف عام، ثابتة في مكانها على مر العصور. ولكن لما هي هنا يا ترى؟
So if we stop here, we see some carvings in the rocks. Definitely man-made, right? So the question is, why did somebody out here decided to carve this game? I think it's a game that's played in Southeast Asia. As we know, sea level changed over time, and we will see this, that 6,000 years ago, we know sea level was about 2 to 3 meters higher. When we look out there and see the sea and consider 2 to 3 meters higher sea level, then the sea was probably here close by, and people were sitting here playing the games, fishing.
وهل ولدت هذه الصخور من البحر؟
This rock was formed by carbonates. This type of sedimentary rocks is 99% formed by organisms, and we can actually, when we get close, we can still see them in the rock. Carbonates, as we call it, are born in the sea, right? They're still there where they formed. So this dune formed here, and it's still there. For whatever reason, it is preserved. And when we later look at beaches and lagoonal environment and rocks that form there, they will stay there, right? They're not moving around. still about 50% of all the hydrocarbon reservoirs are actually in carbonate. As geologists who work for the oil and gas industry, we look at the rocks not only because we're interested in the rocks, but also how much hydrocarbons can be in the rocks. So often people say we're not drilling on rocks, we're drilling for oil and gas.
When you're considering if there's a discovery, if there's some oil or gas that's been discovered someplace around the world, and one of the first questions is how much is there?
Which part in the subsurface contains the best porosity? Because the porosity controls the volume, right? The more porosity, the more volume you have. Pore space between the grains, the better, because more hydrocarbons can get in. But we also want to, of course, produce the oil, right? We want to get it out. So if these pores are too small, then either you get nothing out of the ground or it takes too long, and that's called the permeability.
وتبدأ الرحلة بحثاً على أدلة على إمكانية وجود النفط والغاز. لقد بدأ الجيولوجيون للتو رحلتهم عبر هذه الأراضي الرطبة الغامضة، وعلى الفور انصب اهتمامهم على ما يكمن تحت أقدامهم.
Start getting into this environment and start making our way out ultimately to the beach, which is just kind of walking along this profile.
Lift it up.
There he goes.
There you go. So this is some of the bigger crabs. So when we walk through here, we see basically two types of burrows, right? I mean, we see these big burrows and we see these tiny ones. And the tiny burrows are actually done by a very tiny crab that chews on the sediment. It basically rolls the sediment in front of the mouth and creates these balls. That's actually the sort of life we would expect in this intertidal environment. So when we talk about intertidal, we talk about an area that is covered by water during high tide, but is exposed during low tide. And that's what we see here. When the tide will go down, all of this area here will be basically exposed. We also see that there's a lot of snails around. They really like this environment too. And like these tiny crabs in their tiny burrows, they also feed on the organic material. But we see the grazing traces of these snails.
And so what we end up doing as geologists is we look at the rock, we try to understand how the sediment that's making up the rock was deposited, and then we think backwards. What was that environment that gave us that rock?
المكان يعج بالحياة، سرطان البحر، الحلزونات والأسماك. المد يحمل في طياته جميع العناصر الغذائية الضرورية لبقاء هذه المخلوقات على قيد الحياة.
Suburbia, this is crab suburbia. You can see here, you see how the water is going out? That's because the tide is dropping. Here's our friend.
Yeah.
Who came by earlier.
Without the bigger ones, right?
These are called ghost crabs, the big ones.
The big ones are the ghost crabs, yeah.
But they are actually predators. Now we're walking through this wider lagoon and tidal channel area, and we could see that we get additional fauna, right? The fauna over there, we had a high abundance on snails, but the diversity was very low, right? It was basically only snails. Now we get also bivalves, right? So the diversity changes, and the more open the environment, the more diverse your fauna gets, right?
And by open, we're talking about the more open you are to the ocean water.
Yeah.
Because the salinity changes, so the chemistry changes, and it's a happy place for more critters to live.
And we start getting seagrass. Seagrass we didn't find over there because the salinity was too high.
So no,
to the beach.
We've got to go this way. We're gonna go this way and then go out to this beach bar right here. We looked at the lagoon, we crossed the lagoon, and now we're over here on this beach bar. In this case, we have an environment that is a tidal channel. On one side, we have low energy, where we're depositing material, we're depositing the sediment, and on the other side, we're actually eroding that sediment and moving it somewhere else along that tidal channel. And one of the opportunities that we have here is Christian's going to be able to take his acrylic tube and then pull out a small sediment core that will show us what things look like in the sediment record, which ultimately, if it becomes lithified, turns into what? A rock.
We could actually already see that rock is forming basically as we speak, because what PJ pointed out, the cut bar where the channel is eroding the sediments, it cuts down into this already lithified rock. You can see sticking it out, and it's also underneath our feet, right? It's already partly cemented, right? It's not that hard, we can still crumble it, but it's already starting to cement. And we talked about this before. That's really a speciality of carbonates, right? That they cement very fast. Totally different to sandstones. And carbonates experience cementation or lithification, as we call it, or forming a rock even before they're buried. Yeah, and that's basically how a core of the subsurface would look like, right? And when you start at the base, I think you can see it. It's really finer grains here, the darker ones, more organic rich. Then you have layers that are pretty coarse. We also see areas where you have big holes, right? And this is what we call beach bubbles. When the tide goes down during low tide, the sediment is filled with air, right? So when the water comes back, it pushes out the air, it moves the grains around, but they won't fall back in the same position they've been. So they form these bridges. They're always horizontal to the water table, and therefore here you can nicely see how horizontal they are, and they are preserved in the subsurface, so they show this extra porosity, basically.
But when you lithify this sediment, you actually preserve these structures. So what you're actually doing is you're capturing part of that history and part of that story, not only from the grains, but from the way that the grains are oriented. You can see the beach bubbles here.
Right. So you see how it bubbles. Yeah, you can actually nicely see it. You see it nicely bubbling, right? So the air is escaping, and it actually can see how the porosity is formed within the rock, right? So that's
If this sediment core was turned into rock and lithified, then we would preserve really good pore space, especially in the upper 2/3 of this sample. And then that pore space would be connected. It's not just one thing to have pore space that can hold oil or gas, but it's connected pore space that makes it flow really well. There's some other elements down here below. We get organic material. Now this wouldn't be enough to make a source rock, but if you have thick section of these organically rich layers that get buried further and further and further through the earth through time, then they can cook under pressure and temperature, and they can bubble up. Well, when they bubble up and they find reservoir like this, then they have space to fill. If I took another thick shale section above that was tight, it could trap those hydrocarbons there. So we have like a little mini model of a hydrocarbon system here with a source, a reservoir, and then we'd want to have a seal above to trap it.
If you're looking at drilling an exploration well to actually prove up that this is a reservoir with economically producible hydrocarbons, kind of the rule of thumb across the industry is about you're 25% successful. And it's just, there's a lot of uncertainty. You could have a hydrocarbon system in a basin, but if your top seal wasn't in place before the oil moved through, then the oil's already gone and then the seal's in place and then you don't have what you need. So you need those elements to come together both in space and time. And it's a challenge to find areas where you will have all of those elements come together. And so the timing was just perfect in this part of the world.
وأثناء عبورهم لهذه الأرض السحرية الموحلة، كريستيان وبي جي يتوقفان لتأمل المنظر من حولهما. هل تملك هذه الرواسب السوداء القدرة على أن تصبح خزاناً للنفط في المستقبل؟ ربما لا، ولكن في حقيقة الأمر وجودها أهم من ذلك بكثير.
But see where we stop here?
Yeah, so here's where the transition from the different morphology to the polygonal.
We're now pretty much at low tide.
Yeah, it stays
intertidal.
wet. It stays wet. Nice green algae.
Yeah.
It's a true mat.
It's a true mat. So they are not really algae, they are microbes, even they are called blue-green algae. This area in basically the lower intertidal zone, we get this pretty thick, what we call microbial mats. And the really special thing these microbial mats or these microbes are doing, they can do photosynthesis. They're probably the oldest form of colonial life on Earth, and they're around about 3.4 billion years, right? But 2.5 billion years, that's what we call the great oxidizing event. They really had filled the atmosphere with oxygen. That's what we call extremophiles, right? Organisms that live under very, very unfavorable conditions, we would say.
Look at that.
Oh, yeah.
Lots
so
of
the
oxygen.
oxygen's coming up. We have a chance to survive, right? These microbial mats are also preserved, and we find them in 250, 150 million-year-old rocks. And if we see them, we know exactly we're in the intertidal. This gives us an idea where the beach might be. This is, of course, not a very good reservoir, right? This organic rich could become a source rock if it's extensive. A wipe off the aragonite.
When you think about fundamental resources like food and water, oftentimes that's set up by the geology. And the geology sets the landscape, and that sets the climate, and that sets, what what resources are available, long before modern day civilization, right? And then now we have natural resources like oil and gas that are a big part of our civilizations, all set up by the geologic history of the area. It sets everything up. It's hard to say one thing, right? It's why a valley can provide food for an area. It's why the mountains catch the water and the snow that provide water for an area. It's the same thing here in the Middle East, right? And you look back through the history and where people have lived through time and flourished, and it's all set up by the geology. We're trying to understand that, with Al Ruwais being a modern day living tidal flat, we go out there and we see the mangroves, we see onshore, we see the channels, and then we see in one given day, the tides come in, the tides go out, and it changes the landscape before our eyes. We're trying to understand, in this area, it's really unique because when you have land and water come together, and then the magic kind of happens, right? People have been drawn to coastlines forever, many civilizations, and you can see that interplay between land and water at Al Ruwais take place, and changes can happen very quickly in the landscape.
وتستمر الرحلة ويستمر المشهد من حولنا في التغير ليتحول إلى منظر مدهش شكلته القوى الهائلة للمد والجزر.
That wind picked up a little bit. It feels a lot better.
So to try getting through here, or?
Yeah, we can try.
Wow.
Hopefully we don't go to our knees in mud.
Can we go through? Yeah, now we really look like geologists. Yeah, you see them on the right?
Yeah.
It's actually good. We should have our machetes out and we cut our way through the jungle.
This is great. There's still water in here. Sally said it was bone dry before. So you want to walk around this way and then
I think should we walk cross over? Or we can walk in the channel actually.
Yeah.
Huh? Yeah, look at these nice carbonate sand ripples. And we see when that's actually the ones formed during the outgoing tide, right?
These are awesome. Really pretty.
And in order to form these, let's call it mega ripples, you really need strong currents, right? And strong currents, of course, means you winnow out all the fine material and you create a really nice, coarse-grained carbonate.
Anytime you've got a difference between coarse grain and fine grain, it's giving you an understanding of the differences in energy with respect to, in this case, the movement of water.
Actually,
Oh, there you go.
here we go, right? Finally.
So right here.
See the change in grain size? And again, these tidal channels, they act as the plumbing system of the reservoir.
And then believe it or not, these can actually be much, much larger in the geologic past, to the point to where one tidal channel complex would be twice the size of this entire area that we're studying here at Al Ruwais. So the rock, the sediment that we're standing on here would be of high reservoir quality, and the mud in the tidal flats where the mangroves are would be low reservoir quality. And that's what makes a place like Al Ruwais special, is because we have an opportunity as geologists and engineers to actually come out here, visit this area, and it starts allowing us to gain an appreciation for what we would see at depth. So field work is critical for being able to have a geologist who has seen enough. There's an old expression, the best geologist is the one who has seen the most rocks.
على بعد أمتار قليلة إلى الأمام، وراء هذه الغابات الصغيرة من الشجيرات والأشجار المتشابكة، وها هو ذا نجم هذا العالم الموحل، البحر. قبل مئات الملايين من السنين كان البحر هو العامل الرئيسي في تكون موارد النفط والغاز الغنية في المنطقة من غياهب الماضي وحتى وقتنا الحاضر. وعلى مر ماضي دولة قطر الجيولوجي ظل البحر عاملاً رئيسياً في تشكيل هذه الأرض التي وإن شق التصديق لم تكن تبدو دائماً على هذا الحال.
This has all something to do with sea level variations, right? And we learned that sea level variations are triggered by the waxing and waning of the ice sheet. 18,000 years ago was the time of the last glacial maximum. And you see Qatar being here. And 18,000 years ago, sea level was 120 meters lower. There definitely was no seawater in the Arabian Gulf. You also see that there's a lot of green. So some researchers really think that 18,000 years ago was the end of a very humid period where we had a lot of rain, and the environmental conditions in the Arabian Peninsula were totally different, right? You see we had rivers flowing from Saudi Arabia into the Gulf. So there was really no seawater in the Gulf, only freshwater, two nice freshwater lakes, raining every day, people were happy, everything was fine. 14,000 years ago, climate changed, right? We now see on the satellite image that we have arid climatic condition. Nothing green anymore, no rivers are flowing anymore. You can actually still see the imprint of the Wadi Batin, but what you also see is that now we get the flooding of the Gulf, right? And if we jump to 8,000 years, we see two things. First of all, now the whole Gulf is filled with water. We also see now it's green again. So from 8,000 to 6,000, this time around, we had again very humid conditions. In the middle of the Rub al Khali, for instance, Saudi Arabia, researchers find lake deposits with bones from crocodiles and hippopotamus, so that was a totally different environment at the time. Now when we finally come to 6,000, the magic 6,000, the age of the corals and the beach, we now see why we have the beach on land, right? Because now the sea level was 2 to 3 meters higher, and you see Qatar is now basically surrounded by water, only connected to the Arabian Peninsula by a couple of very narrow isthmuses. But this shows you how the coastline of today, which is in red, was flooded 6,000 years ago, and why we have this beach on land.
انتهت رحلة هذا الفريق من الجيولوجيين عبر هذا العالم المعقد العالق بين المد والجزر. وأثناء مغادرتهم للمكان وصلوا إلى حافة الصحراء وعثروا عليه الشاطئ القديم.
But this is the old beach, right? So this one, Christian, we've been able to measure this one to 6,000 years using C14.
And we can nicely see how it basically, how the sea was coming in, moving the gravel of the older dammam around. We can really well see it here.
At the base. This is very, very diagnostic of sea level rising up on older rock.
It really shows us when the sea actually arrived. And we age dated these rocks from these tiny snails, from these cericids. We got an age of about 6,000 years. So we used carbon-14 for this age dating.
And in terms of a reservoir rock, even though one's a dune and one's a beach, it's going to have the same type of what we call reservoir quality. So again, we're talking about that distribution of porosity and permeability. Porosity is what allows you to store the hydrocarbons. Permeability tells you the ease at which those hydrocarbons are going to move out of the rock. And so high porosity, high permeability makes a great reservoir quality rock. And in both cases, both the dune and the beach, they are going to be of some of the highest reservoir quality that you can get in any reservoir.
Let's see what lies behind the beach and the dune.
Yep, and here we are.
Mashallah.
Wow.
The story ties together.
We've seen this before, right, Ahmed?
Yeah.
That's
These are the
spectacular.
nice polygons. The microbial mat we saw.
all Juma.
And the microbial mats, it's so continuous,
Yeah.
right, along the parallel to the coastline.
Yeah, behind the
Look in
beach.
either direction and we see the same.
What's really nice is that you can stand here and you can see these geometries, these kind of polygonal geometries that are, diagnostic of these microbial mats that are forming, and you can go and see where they're actually living today, and they have the same geometry, the same morphology, kind of sitting in the same environment in terms of, certain distance back from the beach itself. And so it's just a really nice opportunity to kind of see that story through time, 6,000 years ago and then today.
Yeah, there's a repeatable order to it all, right? How it all hangs together and like you said, the geometries and the position.
And because we know these microbial mats won't grow in what we call supertidal or on land, right? And that really proves that there had been water here at some time, right? And with our age dating, we know it was 6,000 years ago. And this really proves that 6,000 years ago, sea level was about 2 meters higher. And we see this along the whole Arabian Gulf.
My hope is, as Qataris watch this documentary and get to learn a little bit about kind of their own backyard, that at least one little girl or little boy becomes inspired to want to understand the natural world around them and then starts asking questions. How did this form? Why did it form? And what's going to happen in the future? And how do we protect what we have today? And if one of these little kids become a scientist because of it, then that would make me one of the happiest people in the world.